Graphical User Interface, or GUI Development. This nugget is probably much anticipated by some of you. We're finally going to move beyond the so-called console-based application in which all input, processing, and output is rendered in non-graphical text. Here we're going to start by understanding what GUI toolkits are and specifically what choice we have in the Python programming language. Because it's bundled with CPython and because it makes a really nice all-around beginner's GUI toolkit, we're then going to look at tkinter toolkit in particular, and I'll show you how to build graphical user interfaces using those classes. Let's get to work. First, there's the preliminary question, why are we interested in building a graphical user interface? Isn't a console or command line based utility enough? Well, yes and no. It's a different programming paradigm, really. We've come to learn Python by starting off with more of a procedural model. Then I brought in object-oriented programming. With graphical user interfaces, you're really turning or shifting your paradigm yet again to a more event-based methodology, in which the application opens and literally sits there doing nothing and waits for the user to do some action on one or more controls in the application. Quite frankly, now that we're in the 21st century, I would hazard a guess that most users, end users, are going to want a graphical user interface. Not all of us are science, math, computer science geeks who are really comfortable in a console environment. So that out of the way, we know that we want to build a GUI application. We can build and deploy cross-platform desktop applications in Python using these GUI frameworks or GUI toolkits. In the Python literature, you'll commonly see references to frameworks or toolkits. They're about the same thing. What a toolkit or framework is really at base is a collection of classes that you can subclass from or instantiate objects from directly. That'll obviously save you a lot of work having to just start from scratch. Now in this nugget we're considering, as I said, desktop windowed applications. A lot of folks just don't even like the desktop application domain. Users are so used to nowadays being connected to the internet, and many software developers think, well, the browser needs to be the interface element, not some desktop application. I wish we had time to go into the pros and cons of each approach. The good news, though, in some, is that there are frameworks available in Python for web application development. In addition, we're going to close this course, actually, with a survey of many Python web frameworks. But yet again, here we're dealing with cross-platform desktop applications. Another vocabulary term that we need to be familiar with that comes up a lot in Python GUI development is the widget. Widget is what's called a portmanteau, a combination of two words, window and gadget. Essentially, any graphical user interface that you've used, whether you're on Mac OS X, Linux, or Windows, is going to be composed of one or more window objects or frames. tkinter in particular has a model with layered windows or framed windows that remind me a little bit of layers in the Adobe applications, where you can lay other elements within that graphical user interface window. Things like buttons, text boxes, labels, icons, etc., and arrange those on your grid or on your geometry to whichever way best suits you and your users. Composing the interface is an art and science unto itself, to be sure. There's courses, there are books, there are computer-based training wholly devoted to good user interface design. Once you have your gadgets arranged on your canvas, as it were, the heavy lifting begins when you write event handlers that will respond to when the user initiates something like clicking a button, checking a checkbox, unchecking a checkbox, putting text in a text field, and so on. I've culled several graphics from doing a Google image search. This is a representative example of a tkinter-based Python graphical user interface. Now, of course it's humongous, of course it's cumbersome, of course it's too busy. This is obviously a proof of concept just to show you some of the variety in controls or widgets, remember, that tkinter and Python GUI toolkits have. You're used to a windowed environment that has your standard windowed control buttons: minimize, maximize, restore, close. You can do scroll bars and resizable forms. We can do menus. That presents a nice compact way to put functionality in your user interface. Lots of buttons. You notice we have these layers or frames, also good for organizing more complex form layouts. Text boxes, single-line text boxes, multi-line text boxes. For mutually exclusive choices, we have the radio button control. For additive choices, we have check buttons. We have the option menu, also called the pop-up or flyout menu. We have the drop-down list box. This is all pretty standard fare, stuff that we might take for granted in the end-user applications that we develop. But as I say, and I can't stress this enough, when you're using Python to develop an application and you've decided that you want a graphical user interface, it's important to make sure that you're choosing the correct widget for the job for the sake of ease of use and performance. Before we delve into tkinter, which is CPython's native built-in packaged GUI toolkit, I think you should be aware of at least these three popular GUI toolkits: WXPython, PyQt, and PyGTK. All three of these are ports or bindings to Python of a cross-platform GUI toolkit. Traditionally, the cross-platform toolkits are written in C. WXPython is a port of the WXWidgets framework, some popular applications that have been written that are available for download that rely upon WXWidgets include the original BitTorrent client and the Dropbox client utility. PyQt, Qt, is the name of the general cross-platform toolkit. This is really popular and you can develop some really nice looking user interfaces. Quite frankly, tkinter is nice to get started with and it's fairly functional, but you'll want to look into one or more of these three toolkits if you want to get into some really good looking GUIs and well-performing GUIs. For those of you who are familiar with Linux, you're, I'm sure, familiar with the KDE desktop environment. That's written using the Qt toolkit. Google Earth, one of my favorite applications, is a Qt application. The Opera web browser and my favorite media player, the VLC media player, all were developed with Qt. And again, PyQt is the Python port of the Qt toolkit. Finally, we have PyGTK. The GTK Plus library, C library, is a graphical user interface library that's used, again, for you Linux people. You, generally speaking, have a choice of either KDE, and the other big player in a desktop windowing environment is GNOME, also called GNOME. Another, the open source competitor to Photoshop, GIMP, is also an application developed with GTK+. Therefore, these toolkits are not insignificant. They're not toys. You can develop honest-to-goodness commercial and or open source tools using these toolkits. Turning our attention again to Google Images, I fetched just some representative examples of applications that folks have built using the aforementioned GUI toolkits. This first one shows you a very Linuxy interface that was developed using WXPython. Just your standard issue text box. These are labels, these are frame controls, there's a checkbox, and there's a close and a save button. Pretty straightforward. PyQt develops much smoother looking applications. This is an Ars image uploader utility associated with arstechnica.com. As you see, it features some really slick user interface elements: menus, thumbnail images, masked passwords, spinner boxes, as they're called in the Windows GUI world. We have a progress meter. This is evidently, well, it says, an image uploading utility. And then for PyGTK, this is, I'm not sure what this application does. I believe this is Arabic here, so I'm unable to read it. But just want to give you a look and feel for what's going on. I believe Arabic reads from right to left, which explains why these controls look like the controls are inverted from what we use in the United States. Anyway, now we come to tkinter. Some folks wonder how to pronounce this framework. Is it tkinter? I call it tkinter, and I think that's pretty much the standard way to refer to this toolkit, and it makes sense when you understand the origin of this word. Tkinter means TK interface, and TK is yet another graphical user interface library that's a part of the TCL scripting language. TCL stands for Tool Command Language. It's a really quite a nifty scripting language. It's also called Tickle. You know, we've come full circle with some pretty corny pronunciations and usages. When you refer to TCL and TK together, oftentimes you'll see this referred to or hear it referred to as tickle talk. Okay, I thought I had a corny sense of humor. As previously stated, TK-Enter does ship with CPython, the official python.org distributions of Python 3.x. In fact, the idle IDE that we've been using all along in this course is itself a TK application. Now that can sometimes cause development problems. That is, if we're using idle to test TK applications, hopefully it makes sense that there might be some conflict of interest going on in terms of spawning a sub-process. You have idle as one TK process, and then your application as a sub-process. If your TK application crashes, that may have an undue effect on idle. However, in my testing with Python 3.1.1, I've seen little to no problems along those lines. We're also going to look at some alternative IDEs in Python in a couple nuggets from now. And finally, frankly, some jock programmers don't even use an IDE. They just simply use text editors and the command prompt to test their application. So you can go that way too. As a point of review, remember TK-Enter and GUI apps in general are event-driven. So it requires a little bit different way of thinking from just a straight procedural approach or from object orientation. Now, the code behind TK-Enter is fully object-oriented. So if you haven't been watching these nuggets in series and you haven't yet watched the nugget on OOP, I would recommend that you go back and do that. So an event-driven application, when we start it, it runs the main loop or the main event loop. We're going to need to include this as a line in our TK-Enter code. And as I stated earlier, the app form just opens. The parent topmost form opens and just sits there and waits for user input. Before we get into completing this nugget with a practical demonstration of using TK-Enter, I want to give you a heads up for those of you who are into integrated development environments, especially for graphical applications. You should know about Visual TK-Enter. This is a GUI builder for Python 2.6, and just from the looks of it, those of you who are familiar with the Microsoft Visual Studio applications should immediately feel at home in terms of you have your graphical drag and drop form designer, your toolbox, you can set properties over here on the right, and even build your application in Windows using the Py to Exe tool. So this Visual TK-Enter will hide or abstract a lot of the coding and heavy lifting that you would have to do normally. I'll tell you, the reason why I like this tool so much is I'm never a fan of manually specifying form geometry. I would much rather just, instead of specifying X and Y coordinates, column numbers, and row numbers when I bind controls to a form, I like to just drag and drop and align them that way. Much easier. Now, enough with me talking, let's get to the demo. To start this demonstration, I want to turn you on to a really nifty application, not written in Python unfortunately. This uses the Adobe Air runtime, so it was built in Adobe Flex. This is called Balsamic Mockups for desktop. Because it's Adobe Air, it'll be completely cross-platform. I'm running it on Windows, of course. And mockups, I feel, in my professional life, I share this with you, are really important for visualizing graphical user interfaces. Balsamic Mockups makes it really easy to mock up not just desktop applications, but you can mock up web browser or web application interfaces just as easy. There's this huge library of all these different controls, common controls, button controls, layout, markup, media, etc. And just with a few drag and drop actions, I've created this simple wireframe here called feet to meters. This is going to be the example application we're going to build in just a moment that I adapted from tkdocs.com. Alright, so that having been said, preliminarily I also wanted to turn you on to some good references for learning TK-Enter. Believe it or not, TK-Enter doesn't have any official documentation. Therefore, quite honestly, a lot of folks just go to Google and type TK-Enter documentation, and it's kind of a crapshoot what you're getting back. I do want you to be aware of some resources that I think are especially helpful. Now, not only is this book by Manning, Python and TK-Enter Programming, one of the only, if not the only, title on the subject on the market, I've gotten a lot of mileage out of reading these Manning books. They have another fantastic volume called the Quick Python Book. New Mexico Tech, nmt.edu, has a document called TK-Enter 8.4 Reference, a GUI for Python. As you see, this is a 118 16-page document. The date stamp on here says 3/27/2010, which as of this recording is super current. And it's essentially an online book free for reading that covers TK-Enter in a pretty good degree of depth from start to finish. Finally, a pretty standard place to go to get TK-Enter documentation is pythonware.com/library. They have an introduction to TK-Enter. There's a much older book. This is 1999, so it's still pretty old. You can look for Thinking in TK-Enter as well. Frankly, I would suggest that if you have some aptitude for this and some literary ability, write your own online guide and share it with the community. Our first example is an extraordinarily simple graphical user interface, but that's just fine because we just want to give a look and feel for how TK-Enter works. From within idle, I'm going to run this module, and we'll just take a look at it first. This is a simple application, one parent window, that's all. The title text is Button App. We have one label control that says I am a button. We can minimize, maximize, close. We can resize. I'm just leaving all the behaviors at the default. You'll notice that as we resize the window, the button and the label remain centered on the form, and then if we click quit, it quits. So I've wired that up appropriately. Now let's come back and look at the source code. The first thing we're going to want to do is make all of our classes available from the TK-Enter module. Now generally speaking, you'd want to use the from import syntax here so you don't have to keep retyping TK-Enter dot, TK-Enter dot. You remember, if we use from TK-Enter import, we're going to bring all of the TK-Enter names into the current namespace. Now we run a little risk of name collision there, but as long as we're creative with our names, we should be just fine. Next thing we want to do is create the root or parent window. This can have any name, but general convention is to call it root. And what we're doing here, you know from object-oriented programming, is that we're instantiating an instance of the TK class. This is going to give us our base form. We can then begin accessing built-in methods and attributes of that class to begin to decorate or mark up that object. For instance, root.title enables us to pass in a string that gives us the window title. Next, we're defining a label control, and the way named attributes work is similar to how if you've used XHTML, those named attributes work. In other words, we have the label, which is going to transparently instantiate an instance of that class, and then in parentheses we can add a comma-separated list of named attributes. Here, I'm just giving one, text equals, but you can also do a whole lot more. Like for instance, down here, when we instantiate the button on the form, we're providing the label text, and we're also wiring code to that element by passing in the command keyword. So back up to the label, I am a button, and then we're attaching the button to the parent form using the pack method. You notice that we've packed both the label text as well as the button on the parent form. And again, to learn all of the different named attributes and these methods, they're not coming out of thin air. The best thing you should do there is study a comprehensive TK-Enter guide for that. Pad Y means that we're going to pad from the y-axis 15 characters. Now, when we wire up a button to a function, it's just a case of setting the assignment operator to the name of the function, and of course we have to have the function defined in our code elsewhere. In this case, the quit app function is going to call root.destroy. The destroy method is one of several ways that you can quit a TK-Enter GUI application. Last but not least, we have root.mainLoop. This is going to kick off the main event handler routine for our TK-Enter application. We're always going to need to have a call to main loop, otherwise the application won't run. Our next example application is adapted from tkdocs.com, and this looks, I think you can immediately see it looks cleaner and looks better than the previous application. We have a nice window border here, etc. The reason for this, and I'm just going to walk through the code having the application in the foreground, is that we've not only imported the names from TK-Enter, but we've also imported the TTK submodule. TTK is a themed widget set that as soon as you import those names, they will overwrite the names in TK-Enter, which are a little bit clunky. So TTK gives us more stylish, let's say, widget controls, and also intends to separate the appearance of a widget from its behavior. Okay, similarly to how in semantic web programming we want to separate the structure of a page, like with XHTML, from its appearance with cascading style sheets. What this application does, feet to meters, very simply, is performs a conversion between, you guessed it, a certain number of feet, and then when we we click calculate, it does the translation to the number of meters and populates this middle area here. Now you might have noticed that as soon as this application started, our focus was on this entry box, or this text entry box right here. That again was included in your code design, or in this code design I should say. So walking through the code, after we import our names, the first thing that we're doing here is defining the calculate function. And we're being really liberal in our use of arguments. We're just using *args, which as you remember is an arbitrary number of input arguments. We're also running try here in order to catch a value error. The value in the try statement is going to invoke the get method and attach that to feet. Now, get should be pretty self-explanatory. It's going to allow us to input data into that text box and retrieve that value as a float. If we scroll down to the bottom, we're also using the string var that represents that data as a string. So basically we're getting the data as a string and then converting it to a float. Next, meters.set is actually going to perform the computation, passing in the value that's put in this text entry box and give the output, which is going to be the number of meters. In this case, we're just trying to capture a value error, and pass is just a placeholder. We would have to put our own custom code in here to handle this particular exception if it happens. Root is defined as an instance of the base window, TK, and we're adding the title feet to meters. Next, we're handling geometry. We're creating a name called mainframe that invokes TTK frame, taking first the parent, which is the root object, providing padding all around, and then we're using the grid method to define our rows, columns, our orientation, the column weight, which again is thicker than what you normally find, etc. Feet and meters are defined as strings in this middle area. Feet_entry invokes the ttk.entry widget, and this is this guy right here, where we're first passing in where is this going to be bound, the main frame, what is its width. Text variable attribute allows us to attach whatever we put into that control to a previously defined name. Then we have our label, X number of meters. Then we have our button text, bound to the calculate function, and bound this time instead of in the previous example where we used the pack geometry manager, here we're using grid. It's just a different way to go. In order to set the focus in the entry box, all we have to do is apply the name of the object, name of the widget, and then invoke the focus method to it. In order to do key bindings, it's just a case of base object with the bind method, and you pass in the key bind and then the button to which that binding is attached. So what this means is that we can put in our value for feet and then hit enter to fire the calculate button. As expected, finally, we run the application by invoking main loop. GUI Development Review. I hope at this point you have a really great head start on how to build a working graphical user interface with Python. To review what we've learned in this nugget, we started off with defining what GUI toolkits are, and I gave you a heads up on some other popular alternative Python-based GUI toolkits. For our case study in this nugget, I thought it was most appropriate to use tkinter, since this is the toolkit that ships by default with CPython 3.x. I hope that this has been informative for you, and I'd like to thank you for viewing.